Good afternoon, everyone, and welcome to the Building Locations webinar. My name is Nick, and I'll be doing the presentation with you today. Just like all of our previous webinars, everybody will be on mute, but if you do happen to have any questions at any point during our class, please feel free to go ahead and type that into the questions and answers section in the Zoom panel. And at the end of the class, I will go through and answer any questions that may have come up. Also, at the end of the class, I will be sending out an email that's going to contain a document that covers everything that we're going to be looking at in today's class. Should you happen to have any questions while going over that document, again, please don't hesitate. You can reach out to our support department and they will be happy to answer any of your questions. So again, today's class is on building locations. And what we're going to be basically going over today is we're going to be taking a look at some detailed information about understanding what the building locations accomplish in Cadsoft Envisioneer. We're going to be looking at and trying to understand what the building locations do. We're going to be defining some building locations. We're also going to add in a new building location. And then we're going to be looking at the framing options in the building locations as well. So the first thing we're going to do is we're going to take a look at a new drawing. Now, one of the reasons we have templates is that it gives you the ability to create different drawings based off of different templates. So depending on the type of construction you're working with, we have templates that accompany those types of construction. So if you're building just a basic construction with a full basement, you're going to use the new home standard construction. If you're building with steel frame or pole barn or slab on grade, you can choose any one of those templates. The reason I'm pointing out templates right now is because each of those templates has a different building location defined in them. And I'm going to use the new standard home construction because it has a little bit more detail to the building location. So we're going to grab that option right there. So it's going to select the new home construction and we're going to say create. This starts a brand new drawing from scratch, and it is, again, using all of the settings associated with that template. So what we're going to do now is we're going to go through, we're going to take a look at, and we're going to get an understanding of the building locations. And to do that, I'm just going to go down, and you can do this in a couple of different areas. You can go up to settings, if you like to use the menus, and you can select building locations. Or if you like to use the buttons, down in the lower left-hand corner is this little house button. That is also your building locations. And you can see when I hover over it, it actually shows up with the flyout of building locations. Just simply left-click on it once and it will bring up the building locations. Now, defining your building locations correctly is an important part of the design process in Envisioneer. The first thing you should do when starting a new project is define your building locations. Your building location settings determine not only the relation of each story to grade, it also determines the height of your walls, the placement of your floors and ceilings, the head heights of your doors, windows, and openings, and then the framing specifications for your walls. When you draw walls or insert other elements, such as your doors and windows, they are inserted at the current building location, which is selected using your view control toolbar, which we've already opened up. By default, when you open a new Envisioneer project file, there are preset building locations, each of which have predefined settings. And you can edit these settings or adjust these existing building locations or create new ones that suit your design needs. So with our building locations dialog box open, we're now going to be taking a look at how to define our building locations. And as you can see, we have a number of different options available to us now that we have the building locations open. So the first thing you're going to see is this green check mark. This green check mark is just telling you what the current location is. So if you take a look down in the lower left-hand corner, you can see that the actual location that's being highlighted right now is ground floor. That is why there's a green check mark there. That's the current location that we're working with. The next column we see is a number column. Now, the number column is just a numeric, it's an alphanumeric dialog where you can type in any value that you want for your building location numbering system. By default, we just do a numbering system of 1, 2, 3. You can add up to 999 different locations in this building locations dialog, but you can change the sequencing. If you want to do 100, 200, 300 and have subgroups under that, you can totally do that. It is completely up to how you want to define your numbering sequences. The same is true for the name. We give just basic general names like foundation, ground floor, second floor. You can adjust these. It is, again, just a alphanumeric field. You can double click in it and you can change it to be whatever you want. So if you want this to say foundation, first floor, second floor, again, you can adjust accordingly. Next, we have our floor level. Now, the floor level is the height above the top of the floor, the height of the top of the floor to the actual terrain. Now, I like to bring up a dialogue here just to help distinguish exactly what I'm referring to. Just sometimes it's better to have a picture to help you understand. So what we're talking about here is our floor level. So we can see here that our floor level right now is 1 foot 5.5 inches. That 1 foot 5.5 inches is from the top of our terrain to the top of our frame floor. So this is to the top of our sheathing. Or if we're working with a slab, to the top of our slab. That value includes the thickness of the floor and any exposed foundation that we're working with. So if you take a quick look over here at our foundation, we can see that our wall height is 8 feet, but we're only dropping that wall 7 foot 6 inches below terrain. So the math there tells us that 6 inches of that foundation wall is now exposed above that zero line. So that's 6 inches of foundation plus the thickness of our floor. And in here, we're going to be using a 2x10 floor with a 3/4 inch OSB sheathing material for our floor surface. So that is going to add up to our, and we're also going to be including our sill plate. So that's adding up to our 1 foot 5.5 inches. From there, everything else is going to be measured off of the top of your framed floor. So your head heights, your ceiling heights, and your wall heights are now measured from the top of the frame floor to the top of the opening, to the underside of the ceiling, and to the top of the wall itself. And then we have something new in version 17, and it's called 2D cut height. This is the cut line that you would see, pardon me, when you are looking at your floor plan. So when we say we want to have a 2D cut height, usually it's going to be in that 4 foot range because we want to see, whenever we cut through our 2D plan, we cut through a door or a window, we want to see that in our floor plan. So that's where that cut line is showing up. If you did a 1 foot cut line here, so it's going to be cutting 1 foot off of the floor, and you have windows that sit 3 feet up high in the air or in the wall, then you're not going to see that window being cut. So 4 foot is typically where we want to have that cut line, but you can accompany or you can adjust that and make it whatever value you want. But that is what that represents, is exactly where you're cutting to view your actual 2D floor plan. And then the last option we see there is our framing options. And we're going to get into the framing options in just a little bit. What I want to talk about while we're still in here is independent versus interactive controls. Now, items that are interactive will update your previously inserted elements when you change their values in the dialog box. So, for example, raising the floor level of your ground floor by 6 inches will raise the entire building location that 6 inches. Items that are independent will not update previously inserted elements when you change their values in the dialog box. So, for example, raising the wall height of your ground floor by 6 inches will not adjust the wall height of any wall that has been drawn into your drawing. The wall heights recognize what they were inserted at, and they are kept at that value. So just to give you an idea of some of the independent versus interactive, and I'll just go over them just again so you have an understanding. The number and the name are not interactive. It's not going to change anything in your actual drawing file, so you don't need to worry about those. Adjusting your floor level is interactive. So if I adjust the floor level, it will update my model for me. Adjusting the head height, the ceiling height, and the wall heights are all independent. So if I insert any of my elements, I insert an opening, a ceiling, or a wall height, and then the client says, oh, I want this to be 10-foot walls now or 9-foot walls now, and I want my ceiling height to be higher and I want my head height to be higher. If I've already drawn all of that, I'm going to need to go through and manually update the model, but I also want to update the building locations for any further adjustments that I make to the model. So if I need to add in more walls, they will take on the new properties that we have in here. So those are independent controls. They will not update if I change it in the building locations dialog. The 2D cut height is interactive. So if I adjust the 2D cut height in here, it will update in my model. So I will be able to see exactly what's happening when I make those adjustments. The framing options are also interactive. So if I adjust the framing options, which we're going to get into in just a moment, it will update my model as well. So let's go in and take a look at the edit location button in our diagram. So we've already opened this up once. I just want to open it up again just to go through it so we can see what we have here. So we can see here when we click on edit, it brings up the location calculator, and we're looking at this from grade. Now, this dialog contains a diagram that, again, helps us visualize what the settings are attributed to. To edit a setting, all you have to simply do is click in a box, and it will allow you to adjust not only the name, but all of the values associated to it. Just a quick reminder here to remember to indicate feet and inches when editing in Envisioneer. If you type in a number with with no feet symbol adjusted, it's going to assume that it is inches. So if I forgot to add in the foot sign after 8 foot, and I just left it at 8, it's going to assume 8 inches. So all your ceilings will be inserted at 8-inch heights. So make sure you put the actual foot sign in or type in the actual value in inches so that it reverts to feet for you. We're going to click cancel on here. And what I want to do now is I want to add in a new location. So let's go in and select, we're going to keep ground floor selected. And I'm just going to click on the add location button. And when I click on add location, I'm going to get a dialog that's going to ask me to choose the new location type. Now I have two options here. I can use the calculate from an existing location, or I can use the calculate from grade. Now we're going to use the calculate from existing location option first. So let's just select that option and we're going to say okay. This again brings up the location calculator, and you can see it says from existing. And it's saying from existing because we chose that, and it's selected the existing location of ground floor. That is the location we had selected when we selected the add location button. So now what this does is it is actually a running calculator. So as you type in values, it's going to automatically do the math for you and specify exactly where things need to sit. So the first option we see here is top of wall. Now, top of wall is grayed out. We're not able to adjust this. It is going to be a running calculation. So as we enter in values in the open edit fields, it will update this value for us. Then we have our floor level calculator. So if we're adding in a new location on top of our ground floor, we're going to need a floor assembly. Well, how thick do we want that floor to be? So this is where you can start to add in values, and I want you to keep notice of the actual top of wall from grade value that we see here. So again, we're going to stick with what we know. We're going to make that 3/4 of an inch. By just adding in that 3/4 of an inch, it automatically adjusts the wall height. We're again going to do the 2x10, so we're going to do 9.25, and then we're going to do no sill plate. We don't need a sill plate on this because we're building it on top of our framed wall. So it's going to automatically adjust all those values for us. We can also say, well, maybe I don't want this to be calculated from the ground floor. Maybe I want a third floor. So instead of saying calculate from location and saying it was the ground floor, we're going to say calculate this from the second floor. And by just adjusting that value, it's going to automatically adjust our wall height. And then we can type in the name that we want. So let's call this third floor. So it automatically calculated all the math for us by just specifying what location we wanted to use as our default to build on top of, and then specifying our wall heights, our ceiling heights, our head heights, and then whatever our floor cavity needs to be. And it automatically created that floor for us. I'm just going to say OK to that so you can see that it now adds in that new location. And then let's just select ground floor. We're going to say add location once again, but this time we're going to select a calculate from grade option. And we're going to say OK. Let's say we want to build a detached garage into our design. So we don't want it to be on the exact same location as our ground floor. So we want to create a new location that is specified for a garage. So in here, I would type in the name garage. So again, we're giving it a location name. Specify again your wall heights, your ceiling heights, and your head heights. And then how high off of the ground do you want this slab to be? Well, since we're building this with an actual slab, we're going to go in and say, well, I only want this one to sit, we'll say 6 inches off of the ground. So that's going to give us the height for that garage to be 6 inches off of the ground. And we can see that it automatically adjusts the top of wall for us. So there are a couple of different ways to go about creating your locations, depending on what that location is going to be used for. So if you're creating a whole new location like a garage that's going to be calculated from your grade, you're going to want to use the calculate from grade option. If you're creating a whole new location that sits on top of an existing location, then you're going to want to use the location calculator from existing. Again, both options are there for you. All depends on what you need to use it for. So now I want to go back and I'm just going to say OK to that. And I just want to go in now and I want to start to specify some of the framing options. Now, just a note here that the framing options are only going to be available for users that are that own Building Essentials or Construction Suite. You may have some framing options in Pro Architect, but it's going to be limited in its scope. So if you are using Pro Architect and you're not seeing some of the entries that you see on my screen, it is for that reason. Okay. So let's take a look at our third floor. So we added in a third floor, and when we take a look at the framing options, we're going to see that it's set to none selected. So right now it's basically saying, well, this is a brand new location. We have no idea how you want this to be framed out. So what we want to do is we want to start to define what our framing options are for that new location. The first thing you're going to see is load bearing span table. So this is going to be a span table that is going to be used whenever you put an opening into a wall, into a load bearing wall, pardon me. And then we also have the exact same option, but for a non-load bearing wall. So you can have differing opening configurations based off of a load bearing wall versus a non-load bearing wall. So let's determine our load bearing span table first. So right now we can see it's set to none. I'm just going to double click on that. Once I double click on that, it's going to bring up the wall span table library. Now in here, I can define what I want that span table to use. Does my region require a 2-ply span table or a 3-ply span table? Again, this is probably going to be more indicative of if you're building with 2x4 or 2x6 construction. So if you're using 2x4, you're probably going to be using a 2-ply span table. If you're using a 2x6, you may want to be using a 3-ply span table. Again, you can determine that based off of what you're creating. I'm just going to grab the 3-ply span table and we're going to say OK. And then for my non-load bearing wall, I'm just going to grab a 2-ply span table and we're going to say OK. Now, before I get too far away from this, I just want to double click on here again, and I want to go into the 3-ply span table so you get an idea of what it is exactly that this controls. So these span tables are based off of opening sizes. So what's the span of that opening? So as you can see here, for any opening up to 5 feet, it is going to be using a 3-ply 2x6 header. These are the defaults. This is what Envisioneer sends out as its default packages. This may be completely different from what you need in your region, so you will need to have an understanding of how to set these up and what's going to work for your codes in your area. Again, for any opening 5 foot up to 8 foot, we're going to be using a 3-ply 2x8 header. It's going to have a double sill. Any opening from 8 foot to 12 foot is going to be a 3-ply 2x10 header, again with a double sill. And then any opening 12 foot to 16 foot is going to be a 3-ply 2x12 header. Now, what does this actually mean? Well, if we go in and we click on this little area here, we can see that there's a little browse button, and it gives you a little preview of what the framing looks like. I'm going to take it one step further. I'm going to click on that. And then we're going to double click on the, this brings up the head sill library. And in here, you can see all the defaults that we have. So if we go into, and I'm just going to double click on that, we're going to be able to see the head sill configuration. This is how this opening is constructed. Over here on the right-hand side, you have a preview. I like to right click in this preview and just go into a rendered outline mode. I find it is a little easier to distinguish what we're working with. I can see my actual members. When you click on a member in the left-hand pane, it will highlight in the right preview with it being highlighted in green. So as you can see, we have a left and a right king stud, a left and a right jack stud. We also have our headers 1, 2, and 3, hence the 3-ply naming convention. And then we have our sill. We also include an upper and lower cripple region. You do not need to have differing opening configurations for doors versus windows. Envisioneer is smart. It knows if you put a door in, it's going to remove the lower cripple region for you automatically. So one opening configuration will accommodate both doors, windows, and openings. The one thing I do want to point out here is when I click on a left king, left jack, or right king, you can see that the member that is being used is actually the member from the wall properties. What does this mean? This means that if I draw in a 2x4 or a 2x6 wall, whatever wall I define, the properties of the wall is going to dictate the member that is going to be used for the jack studs and the king studs and the studs in the wall itself. So it's going to refer to the wall. It's going to say, you're drawing with a 2x4 wall, then we're going to be using 2x4 jacks and kings and sills and cripple regions. If you're drawing with a 2x6 wall, it is going to use a 2x6 member. The area where it differs is under the header option. So in here, we're saying, well, I don't want this to refer to the wall properties. I want this to be a set member, and we want this to be a 2x6 member. If we click cancel on here and I go into the 2x10 and I click on a header, it's using a member from the member library, and it's now using a 2x10 member. So you can determine exactly what member you want to use for different parts of the wall opening if you so need to. And as you can see with this particular opening, when I clicked on the 2x10 option, I'm now doubling up my jacks and my kings on both the left and the right side. I'm carrying a larger header, more weight, needs more support. So we're going to be doubling up those options. There may even be situations in your designs where you need triple jacks and double kings, or triple jacks and triple kings. You can accommodate that. The largest we go up to is doubles, so you can add to that if you need to create your own configurations. I'm just going to click cancel on there and cancel on there because I don't want to make any changes to this. I'm just going to say OK to that. So now we specified our load-bearing span tables and our non-load-bearing span table. Now we want to take a look at our intersections. Now, intersections are defined based on the way the walls are drawn. So we can't really make any adjustments here other than specifying that we just want to use the turn stud option. Anytime you add in a corner, be it a 90-degree corner, a corner that's on an angle, a T or an X intersection, it is going to refer to this turn stud library and it's going to find the appropriate match for you. Then we have the infill configuration. Now, the infill configuration settings allow you to control the size and the spacing of the stud members themselves, the size and the number of the top plates, and whether or not there is going to be blocking in your wall framing. So if we double click on this one, again, this brings up the wall infill library. And again, it is pre-populated with all of the different infills that we feel you're going to need as a starting off point. Again, this list is completely modifiable. So if you want to add in your own infill configurations to match code in your area, you can do that. As you can see in here, we have 12 inches on center, and we're just going to go into a rendered outline view, and you can see that that is just including a top plate and a bottom plate, and then our studs every 12 inches on center. Then we have a 12 inches on center, but we have the designation of 2x4 pressure treated bottom. So again, if we go into the properties of this, just to give you an idea of what this dialog looks like, we're basically telling that this infill configuration is using a bottom plate that differs from the wall properties. So when we look at infill properties, we are able to determine the spacing. We set that to 1 foot. We have the cut opening bottom plate. Now this is highlighted and this is selected for you by default. And you may ask, well, why is that even there? Well, if you are creating panels that get created off-site, they get shipped with the bottom plates intact, and then those bottom plates get cut on site. So some people want to be able to show it in their plans with the full bottom plate until it gets erected at the site. So they'll keep that option unchecked for their purposes. But by default, it is checked. So the bottom plates will always be cut in any opening for a door. Then we have the options for projecting it into the plates, top extension and base extension. This is not going to be anything that you would use for a wood construction, but it is something that you would use for a steel frame construction. So that's why that option is there. And then we have generate end studs. So do you want to include your start and your end studs? And you can check those to say yes or no, depending on your situation. Now the bottom plate, like I mentioned, we are now using, instead of the stud option where we're saying wall properties, again, if we're drawing with 2x4 walls or 2x6 walls, it's going to use the appropriate stud. We're saying that when I draw a 2x4 wall, I need it to use a 2x4 pressure treated bottom plate. So that's why it's using that there. This is all done so that you are getting the correct quantities in your reports when you draw out your designs. So this way you're going to see exactly how much 2x4 treated material you're going to need as a sill plate in your designs. You click cancel on that, and as you can see, it goes through a total list here. You can see that we have a 2x6 pressure treated bottom plate. We have double top plates. We have double top plates with 2x4 pressure treated bottom plates, double top plates with 2x6 pressure treated bottom plates. And then we do it all over again with the 16 inches on center, all the way down to the 24 inches on center. So you can again get very detailed in the construction of the wall infills that you're going to be using. We can also include blocking. Now blocking again is just going to be included at a set height that you determine. So I wanted to have an initial offset of 4 feet, and it's going to be spaced at the 4-foot intervals. And it's going to also stagger for easier nailing in my designs. I could say no to that and it would just be in line. So you can, again, if you want your representation to be accurate, you can adjust it accordingly. But again, same principles apply to this dialog as it did for the 12 inches on center. You can go through and adjust however you feel you're going to need to for the code in your area. I'm just going to grab the 16 inches on center with the double top plate, and we're just going to say okay to that. And that's what we're going to be using. And we're going to say okay. And then I'm going to do the same thing for my garage, because again, the garage does not have any building location, or sorry, any framing options assigned. So again, this is going to be a 3-ply span table. That's going to be a 2-ply span table. This is going to use the turn stud library. And then the infill is going to be a 16 inches on center with a double top plate. And then we're just going to say okay. We then have a framing rule. This framing rule just allows you to determine where you want the framing to start in your design. So when you double click on this, you can see there's a drop down menu here, and this will allow you to access that drop down to specify what starting point you want to reference for your wall framing. And you can use any one of those options there. And then we're just going to simply say okay. And then when we say okay, we've now updated our drawing, and it's now going to have a new building locations, and we can see that we can choose any one of these building locations and add to that any kind of structure that we want. So that covers everything that I wanted to talk about in regards to building locations. So I'm just going to go over a quick review of everything. While I'm doing that, if you happen to have any questions, please feel free to go ahead and type those in. I will be happy to go through and answer any questions that you guys may have. So just to review, in today's class, we've now learned why it is so important to always adjust your building locations before starting to build your projects in Envisioneer. The building locations dialog is probably one of the most important dialogues in the software, as it controls exactly how your model is going to be built from the very beginning. Just some key points to remember here. The building location settings will dictate the number of building locations in your project to a maximum of 999 and the name of each of those locations. The relationship of the different building locations to one another and to the ground. We're also able to dictate the wall, the floor, and the ceiling heights of each of the building locations. We can also control the height at which the elements such as doors, windows, and openings are placed into our models. And then we're also given the ability to adjust the framing settings for load-bearing and non-load-bearing walls in our project. We also looked at interactive properties in the building locations dialog, which will update items previously inserted into our model when you change their values. As an example, our floor levels and our framing options. And then we also looked at independent properties in our building locations dialogs that will not update items previously inserted into our models when we change their values in that dialog box. And those are going to be values like the head height, the ceiling heights, and the wall heights. So I do have a couple of questions that came in, so let's take a look at those. So the top of framed floor means top of plywood, not top of joist. That is correct. So we are talking about from the top of plywood to grade level, which we've always assumed as 0. And then the next question is, please review again how to turn on and off the automatic wall elevation calculations versus manual entry. I think I understand that question. I'm just going to double check. So please review again how to turn on and off the automatic wall elevation calculations versus manual entry. I think you are referring to I'm not sure what you're referring to there, actually. Are you referring to the when I went into here and the value here where you have the location calculator and it gives you the ability to adjust these values? Or are you referring to the actual properties in the wall? I'll just pause there so you can type out your response to that. Oh, the floor system showing up, is that automatic? Depending on the building location that was defined. So for example, the ground floor and the second floor, in the default templates were not created using the by location. So if you wanted to update yours so that it did, then you could adjust that accordingly by creating your own locations. But since I added in this third floor location and I used the calculate from existing option, I now get this floor level calculator, whereas this one was created from grade. So it's not going to have that floor level calculator. So that's where the differences will vary. It depends on how that location was created. So from grade will not have the floor container option. The from existing will have that value. Perfect. I'm glad that answered that for you. So I'm just going to pause here for another moment just to see if anybody has any other questions. Like I mentioned at the beginning of the class, I will be sending out an email, and in that email will be a document that contains everything that we've talked about in today's class anyways. But should you happen to have any questions going over that document on your own, again, please don't hesitate. Reach out to our support department. They'll be happy to help you out with any of your questions. Perfect. Well, there doesn't appear to be any further questions for today's class. So I do want to thank everybody for attending. I do look forward to speaking with you all again very soon. So thank you very much, everybody, and enjoy the rest of your day.